Hi everyone, we are moving on to areas of oblique triangles. One of the more useful things that we'll learn in this unit because now we can find the area of any triangle even if we don't have the height. Okay, so first, just as a warm-up, they want us to find the missing sides and angles using what we already know. So go ahead and pause the video and try to work this out on your own first. Okay, so I can set up my law of sines. So my ratios are sine of 59 is to 16, as sine of 18 is to b, as sine of 103 is to t. And again, we just find 103 by subtracting from 180. Okay, from here I can solve my ratios. So solving for b and then solving for t, I end up getting that b must be, let's see, we flip and then multiply, so 16 sine of 18 divided by sine of 59. Make sure that your calculator is in degrees, and we'll get that b is 5.768. Okay, here t is 16 sine of 103 over sine of 59. So plugging that into our calculator, we get 18.187. Okay, so first talking about what type of triangles we're going to be working with. They are oblique, meaning they do not have a right angle. And the way that we can calculate the area of any one of these triangles is with this formula here, 1/2 BC sine of A. Now what's important to note is that just whatever angle you're using inside of sine, you're going to use the other side lengths in your area formula. So if you're using sine of A, then you'll use B and C. Okay, if you're using sine of b, you would use a and c, and then if you're using sine of c, you would use a and b. Okay, that's what's important to know. Now real quick, let's just prove this formula. So let's think about what happens if we have a triangle. I'm not going to use this because it looks too much like a right triangle. So let's think about what happens if we have some triangle. I'll make that bigger. Okay, let's call this ABC, where this is A, this is B, this is C, and we have some height, which we'll call H. Okay, now normally, if we're going to calculate the area of a triangle, it would be 1/2 base times height. In this case, base is A. It doesn't really matter. You could name this however you wanted. That's what makes this the proof. But in this case, my base is A. My height is obviously this value right here, but I don't know what that height is. So I want to be able to represent H using B, C, and A. Now, luckily, there's a way that we can do that. Because I see that within my larger triangle ABC, I have a triangle, I guess, A minus some quantity, HB, which is a right triangle. So I can use right triangle trig here, meaning you could use angle B or C here. I'll use angle C, meaning sine of C is going to be H over hypotenuse B. Okay, so that means that if I solve for H, I get that H is B times sine of C. Right, which makes sense because opposite over hypotenuse, and then we're just canceling out, right? So we're solving for one leg of our right triangle within my larger triangle. So now that I have a way to represent my height and my base, I can rewrite this as 1/2. My base is A, and my height is B sine C. All right, so real quick proof of how this area formula came to be. Let's actually walk through an example. So they want us to find the area of this triangle. So again, super simple. My area is just 1/2. I'm going to use the side lengths that I'm not using for my angle. So 15, 13, sine of 71. Alright, so we just straight plug in. We end up getting their area is 92.188. Super simple. Okay, moving on. This time they did not give us an angle, they gave us 3 side lengths. Now what you could do is use law of cosine. So you definitely could solve for angle H or P or J using this. So you definitely could solve for H this way. An alternative is to use what's called Heron's formula. Okay, in which case it's a 2-step process, so it's really easy. The first thing we're going to do is find the semi-perimeter, which we call S. Okay, so we're just going to add all of our side lengths together. So in this case that would be H plus P plus J divided by 2, which is going to give us, let's see, 11.5. Okay, so Heron's formula is great if you have all of the side lengths and no angles. You just add all of the side lengths together, divide by 2, that's our semi-perimeter, or half our perimeter, okay, and then we just plug into an area formula. So our area is the square root of S times S minus H times S minus P times S minus J. Okay, so I plug in. My S value, my semi-perimeter is 11.5. I have 11.5 minus 5, 11.5 minus 7, and 11.5 minus 11. All in a square root. Plug that into your calculator, we get 12.968. So it's much quicker than using law of cosines, although you could use law of cosines and then use the area formula that we previously talked about. Okay, go ahead and give the next one a shot. You can do it either way. I'm going to use Heron's formula, but you could use law of cosines if you want. So go ahead and pause the video and give this a try. Okay, first step is to solve for a semi-perimeter. So 6 plus 8 plus 11 divided by 2. That gives us 12.5. Next, we solve for our area, which is the square root of 12.5 times 12.5 minus 6, 12.5 minus 8, and then times 12.5 minus 11. Plug that into our calculator, we get 23.418. Alright, that is it for these notes, and let me know if you have any questions. I will see y'all later.